If you've ever tried to animate something smoothly in Mandelbulber and thought, wow, that's a lot of keyframes, this video is for you. Hi, I'm Stevemusic, and welcome to Scripting with Mandelbulber. Before we start, let me get something out of the way. Scripting is not programming. You're not building apps, you're not compiling code, and you're not turning into a software engineer overnight. What we're doing instead is describing motion and behavior. We're telling Mandelbulber how things move, how they orbit, how they breathe, rotate, and repeat. And full disclosure, I'm also a musician, which means I usually count to 4 and then I start over again. So if I can do this, I promise you can too. So don't worry. If you can follow rhythm, timing, and repetition, you already understand most of what's going on here. Scripting with Mandelbulber. Why scripting instead of just using keyframes? Mandelbulber's keyframe system is incredibly powerful. See my keyframing in Mandelbulber for all of the details, but it has limits. If you want perfect circular motion, smooth looping, motion that eases in and out naturally, multiple objects staying mathematically in sync, doing that with keyframes alone becomes tedious, imprecise, and very hard to adjust later, especially when you want to add or delete keyframes in the middle, you want to extend links, you want to change the number of frames per keyframes, etc. And then you have to recompile the whole range from start to finish throughout the animation. Scripting lets us describe motion itself, not just snapshots of motion. Keyframes are literally snapshots, and it takes a lot of snapshots to plot a circle. You can try to fake a circle with keyframes, but you'll end up adding more and more points, and it's still never truly smooth. A great example, and one we'll build here, is 3 moons orbiting a central sphere. Smoothly, evenly spaced, perfectly looping, with breathing scale, fog changes, and orbiting lights. That kind of motion is where scripting really shines. The reason scripting is so powerful is because there are certain motions that are extremely difficult or outright painful to do with keyframes alone, such as perfect circular orbits, motion that eases naturally. Everything you'll see in the final animation, the moons, the light, the breathing, the fog, is driven by scripts. How time works in Mandelbulber. Everything in Mandelbulber animation revolves around frames. There is no seconds or time variable. Instead, Mandelbulber gives us frame_NO, or frame number. That's the current frame being rendered. So when we write scripts, we're really saying at frame 0, do this, at frame 300, do this, at frame 600, end up back where we started. In this tutorial, we will use 600 total frames, and we're going to use 2 keyframes, both identical. These keyframes exist only to tell Mandelbulber where the animation starts and where it stops. Important point, you cannot make an animation with 0 keyframes. I've tried. Let me know if you figure it out. But you can make a complete animation using only the 2 default keyframes and scripts, which is what we're going to do. All the actual motion comes from scripting. So yes, we will still use keyframes, but scripting is doing the real work. Finding parameters and the single quotes rule. This section is critical and easy to miss. In Mandelbulber, almost every parameter can be scripted, because scripting in Mandelbulber is just set this parameter equal to this formula. We can also influence the value of one parameter with the value of another parameter and as part of another formula, but we have to know how and what to call that parameter. To find the exact name of any parameter in the format that Mandelbulber uses for scripting, just simply right-click on it, choose Copy Parameter Name. In this case, I'm going into the mothership radius, I'm right-clicking on it, and I just simply copy parameter name. And then when I paste it, it becomes main primitive sphere 1 radius, and it's already got the single quotes around it. You'll see names like main primitive sphere 1 position, main primitive sphere 1 radius, basic fog visibility, each word set off by underscores rather than actual spaces. Whenever you refer to another parameter inside a script, you must wrap it in single quotes. For example, main primitive sphere 1 radius that we just got by copying parameter name plus 5. In this example, main primitive sphere 1 radius must all be enclosed within single quotes. Why? Because you're telling Mandelbulber, don't treat this as a number, look up the current value of this other parameter. No quotes will be an error, double quotes is an error, single quotes is correct. This applies everywhere to parameters that talk about positions, radii, light sizes, fog values. Any parameter value that you reference dynamically from another parameter must be in single quotes. And it will say, look up the value of this other parameter and then do X, Y, Z to it. Vector parameters, with the important reminder about no line breaks. Some parameters are vectors, like position or rotation. They have 3 values, not just one. They have an X colon, a Y colon, and a Z colon value. Vector components of such parameters should be after a dot and all within single quotes. So for example, main primitive sphere 1 position dot X, dot Y, and dot Z. Each one of those is separate, set off by single quotes. Anytime you write a script with a vector, X, Y, and Z, it must stay on one line. What is correct is X primitive sphere 1 position, X plus 2, Y primitive sphere position, Y plus 2, Z stays where it is. It just copies main primitive sphere 1 position. Each one of these is set off by just a space, and this goes to the next line because the line can't go long enough, but line breaks inside vector scripts will cause Mandelbulber to error. No line breaks, no carriage returns. If you split it across multiple lines, Mandelbulber will error. Your word processor will automatically cause it to go to the next line, but it doesn't actually introduce a line break. As long as we don't introduce an actual line break, it would be fine. This rule alone prevents a huge number of beginner mistakes. Opening the script editor and the test button. When you right-click a parameter, like we just did to get the name of this parameter here, which copy parameter name, let's go over here to baby3, and on its radius, let's look at edit script. Click on that. Now we see the scripting window opens, and this is the scripting window for main primitive sphere 4 radius, which tells us what it is at the top. We're gonna, the script for the parameter goes in this line here. It'll even tell us the last parameter that we used and the frame number if we want to use. For the purposes of this tutorial, I'd like to direct you to the test button. So I had just copied the name of main primitive sphere 1 radius earlier, and if I just paste this right into here, as it just by itself, I'm telling Mandelbulber, hey, make the main primitive sphere 4 radius, whatever this equation is in here. And in this case, the equation is simply look up the value of main primitive sphere 1 radius. So if I hit test, that shows me the estimated value. It walks through converting the script into more mathy things, which we won't get into in this beginning tutorial. But ultimately, it says it finishes with no error at all. What if I had forgotten to put the last quote mark on it and I hit test? Error in the script for parameter, there is missing second quote. This will actually tell us what's going on. In this case, we can just add the second quote. Sorry, I can't see. Hit test again, and we're working. I'm going to hit OK for now. And now that'll draw us to the second thing. After we have added an equation to a parameter, that parameter will turn blue. Right now we have radius as a blue line. This indicates that there is a script and it's working. So I can tell at a glance by just looking at our windows here, there are no scripts on anything except baby 3 radius here has a script in it. I can't see what it is without opening it, but I can tell that there is an active script and that it is working. So recap real quick. Script editor, we pasted in a parameter, we tested out the test button. And right now, that's all we're going to do with scripting. We're not going to get super deep into other stuff. We talked about how we know it's working, it's blue. Now let's talk about sine and cosine. And again, let me direct you back to my admonition at the beginning that I am a musician. I count to 4 and I start over again. I did have trigonometry in high school and never went any further. So I have had the basic rudimentaries of some of this higher math, and let me explain it to you as best as I think I can. Let's demystify sine and cosine. Here's the key idea. Cosine starts at its maximum value. Sine starts at 0. They're the same wave. They're just shifted relative to each other. That's it. That's cosine, sine and cosine for our purposes here. Cosine starts at the maximum. Sine starts at 0. When you put cosine on one axis and you put the sine on the other axis, together they make a circle. So this cosine angle, sine angle, really means go around in a circle. That's all an orbit really is. No advanced math, just choosing where the motion begins. That leads us into phase offsets, or spacing things evenly. To evenly space multiple objects in a loop, we use phase offsets. Basically, a full circle is 2 times pi, and right here we can use pi as long as we put a double paren after it. If we use just pi, it won't recognize it. We can put in the value for pi to as many digits as we want, but if we just put pi, open and close quote, that basically says pi, the function of pi. So 90 degrees is pi divided by 2, 180 degrees is pi, 270 is 3 times pi divided by 2. If we apply that to our 3 moons circling the single larger object, that will make them all stay perfectly spaced. Another way to do that space all 3 out, is pi divided by 4, or basically pi times 1/4, pi times 3/4, and pi times 5/4. Doing it that way will space them all evenly out. Now that we've talked about those basics, let's start the scene. Let's build the scene. Let's start a build. So all of you guys have got several of these settings and background textures and whatnot into a zip file, which is in the description. I'd like to take you to the file that basically says Mandelbulber starting scene, no scripts. Feel free to go ahead and open that up. You can either go along with me or just watch what I'm doing and go back to it later, whichever you would like. For now, let's talk about my prepared static scene that I have here. I'm going to hit render here real quick just to show you what's going on. And I made this sphere the same size as that larger sphere. So let me edit that script real quick and just do this clever thing, divided by 4. Hit test to make sure it gives us a value. It does. Okay, so now it says, make the radius of baby 3, whatever the radius of mama ship is, divided by 4. I hit render. And now we've got all these 3. These 3 are just sitting in space right now, not moving. Here we have, as promised, the 2 keyframes sitting here with nothing added to them. These are the default keyframes and the default camera positions. Throughout this tutorial, we are going to do nothing whatsoever to these keyframes. Yet we will have a full 600 frames for our animation. I already have this set up, frames per keyframe. You do need to program in the actual path on your computer where you want to put the actual folder where you want to put these images. Right now I just have D or folders. Okay, we're pretty much ready to begin. We have 1 large central sphere. We have 3 smaller spheres positioned loosely around it. I have what's called greeble, which is basically Star Wars, Star Destroyer, outside pipes and trenches and access ports kind of stuff. I have a greeble texture applied to all of them just to give us something to look at, and also, most importantly, so that we can tell when these things are rotating, because if we just use plain spheres, we won't be able to tell that the sphere is rotating, because there's no surfaces no detail. So these textures and these starting settings are all in your folder to start with. Nothing's animated yet. Everything is static, and this is intentional. Scripting builds on a solid base, but it doesn't replace scene setup. We still have to have materials. We still have to load everything in there. All I'm wanting to do is I want these 3 little baby moons to circle the mama ship. I want them to go in nice, complete, smooth orbits. If I was doing this in keyframing, this would be extremely difficult. It would take me a number of keyframes. I would plot it out, and I would get roughly there. Mandelbulber has a number of shaping algorithms that will smooth some of these jerky keyframes and try to make it something approximating a circle. It would take me forever, though. I would physically have to move the camera each time and take a keyframe, take a keyframe, take a keyframe. If I wanted to make this video longer or shorter, I'd have to go back and change everything. It would just be chaos. So let's animate all of this with scripts. I also have some lights that are just stuck on there right now. They're already colored, already ready to go, but there are no scripts whatsoever. So that's the scene. So the first thing I want to do is I want to be able to introduce motion to this first moon here. I'm going to go to my set of scripts and copy and paste. This is also one of your downloads. All the scripts are downloaded. Or all the scripts are provided for you to download and just copy and paste. We're going to walk through them, break them down. You can create your own. I'm going to provide you sample templates. And in the future, we're going to get really, really deep into scripting for another video. In this video, we're going to keep it very surface level, very, very easy. Okay, let's make this moon move. I'm going to pick this moon right here in front of us. That's the easiest to see. It happens to be baby 3. And I'm going to put an equation into it, and let's get it to move. Okay, let's make the first moon move. I went to the scripts, and we have all of the scripts here. Script primitive sphere position 2, 3, 4. Primitive sphere 1 is just in the default position, so there is no script for it at the moment. I want primitive sphere 4 position, so I'm going to copy all of this, making sure there is no spaces. In fact, I'm going to turn on toggle formatting. So we see in this equation that there is just a dot between the X single quote and the Y. We want to make sure there's no line breaks, no carriage returns. So I'm going to copy all of that to the end of here. Simply copy, go into my Mandelbulber, and sphere baby 3, which is actually primitive sphere 4. Hopefully that's not too confusing. Here in the position, we'll see that position is a vector. So we can click in X, Y, or Z, it doesn't matter. We're going to edit script, and you'll see on the scripting window, we have X colon, Y colon, Z colon. This is the default parameters for vectors. I am going to select all of that and just Control V, all of that equation in there. That's a big long equation. You'll see X, bobbity blobbity. We're tracking main primitive sphere 1 position. We're tracking Y main basically we just said X is the same as Y. We're saying for this sphere, give us the same X component of your vector as the mama ship. Y, however, we want to take her vector and add this equation to it. Z, we want to do the same thing. In the Y, we want to go cosine. In the Z, we want to go sine. When we go cosine in one direction, in one axis, and sine in the other axis, that makes a perfect circle, we hope. So we're going to hit test to make sure we've got this value. It looks like it produces no errors. Everything looks good. So we're going to hit OK. And now when we look at this pane over here, we see that the radius still has its script that says keep our radius, whatever mama ship is, divided by 4. And now the position, we'll see that X is 0, and it will X will remain 0 throughout, but the Y and the Z will track with the position of the mama ship. Now, were I to move the mama ship around, this one satellite would continue to orbit it wherever it is. So I can move this around and have this continue to orbit it in a beautiful, beautiful manner that is absolutely impossible to do in keyframes. To move this sphere and have this sphere follow it while it moves, I just couldn't do it. I'd have to animate it frame. I'd have to put a keyframe on every frame actually to make that happen. But with scripting, I've just done that. So let's animate it real quick, and let's run the 600 frames. I have two keyframes here to give us the start and the stop. Nothing else on there. The only scripts working right now are on baby 3, telling it stay a quarter the size of mama and rotate around it in a circle. So let's run those 600 frames and see what it looks like. So if you see my net rendering in Mandelbulber video, you'll see what I did here to connect another computer with another set of rendering. But basically, and I only have just one other computer at the moment going. I have a third one in the basement that I just haven't bothered to turn on. I'm going to hit render as I normally would for an animation. Yes, let's delete anything that was in that. And we're going to, in fact, let me also caution you not to render this at 4K. I'm going to hit connect fractal detail with image resolution. Basically, that says keep the detail the same way it is, even though you shrink it, so that now it will render. It pretty much looks exactly the same, just a lower quality, and it renders almost instantaneously. So let me delete all that out that we just made. I don't think anything rendered anyway, but hit it again. So we're going to render through these 600 frames real quick, and we see in our animation, Mama Ship sitting there. We haven't done anything to it. It has no keyframe or script to move, but baby ship number 3 here has been told to rotate around mama in a circle. So we're not going to track that through all 600 frames here. Just wanted to let you know that the script is working. We'll go over to see the script working. Blue. The script is working for the position and the radius. We don't have any scripts anywhere else. We can look at, say, baby 2, no scripts, baby 1, mama ship. But here at baby 3, we're rocking 2 scripts that are making it move around this thing. Okay, so we're at 170. Let me, through the magic of editing, speed through this, and I'll catch you on the other side. All right, looks like we're coasting through the last of the keyframes. Let me hit show animation here. I still got 20 or so rendering in the background. We'll get to there. So right now, I'm just going to scrub through the timeline, and we see, look at that, one complete circle. Cosine, sine, cosine, sine, boom, all the way around. One complete circle, and we are done. There's our 601 frames. Nothing else moved, but we have successfully used scripting to do the first little animation here. Lights didn't move, nothing else moved, but proof of principle. We have moved this, and then I'm going to take this right here near the end, hit play, and just watch it seamlessly loop from one video into the next. Seamless loop, seamless loop, seamless loop. Look at that. Mathematically perfect. Took us 2 seconds to chunk in that script. Took a little bit longer to come up with that script. But in terms of efficiency, scripting is super easy and powerful. As soon as you learn it, then you start saying, well, what else can I script? Let me script this thing to move with this thing, and then something else to move with it, and something else. So you have something rotating, a thing that's rotating, another thing that's rotating it. Yeah, I've taken that a few Inception levels deep, and it's pretty cool, actually. It's fun just to play with things rotating other things while you move one thing around all over the screen, and everything else just follows right after it. It's pretty cool. Okay. Let's plop in equations for number 2 and number 3. Let's go to baby 2. Let's get our scripts for baby 2, which is actually sphere 3. I'm sorry, I could have just made mama 4 instead, but no, I had to make mama 1. So baby, let's see, I want primitive sphere 3, chuck that in, copy, and we'll just do this in reverse order. We'll go to our position, edit script. I'm going to select all that just to make sure that I don't leave any behind. I've pasted in my script. I hit test. It seems to work. And now it has put the position parameters into blue for me, indicating that there is a script here. Let me just get the one for the last one. Number 2. Let me start it this way, other way. There we go. Making sure I get that ending quote there. Control C to copy, back over to here, right click on any one of those 3 parameters to get edit script. Oops, sorry, I have gone to the wrong one. I wanted baby 1. Here we go. Position, edit script. There's the default XYZ that we're going to Control V paste into. Give it another quick test here just to make sure we copied and pasted and didn't leave any values behind. Okay, so now I have all 3 scripts, all 3 babies. One thing I want to do, I want to go into the radius that we put and copy that, go into baby 2 and edit script. Gonna give it the same, take mama's radius divided by 4. Now that's only makes a deal if we start changing mama's radius, which in the purposes of this tutorial, we're not gonna change mama's radius. But I just wanted to show you proof of principle, test that real quick. There we go. So now I have all 3 babies with their position and radius set to mama. Let's delete out all the images that we just rendered, render this puppy down, and we'll see all 3 moons are moving. Let's go back and look at while that's rendering, let's look at the equation itself. We'll see that the offsets were that pi divided by 4, pi times 1/4, pi times 3/4, pi times 5/4. Doing that gives us these 3 moons offset from each other. But if you look at the scripts, you'll also notice that each 3 is operating in a different plane. In the first baby, you'll see we're only changing the x and y. We're going cosine in x, cosine in x, y in sine. In 3, we're leaving y alone and z is the sine. In 4, we're leaving x alone and we're doing yz. So each of these, this one circles in the xy plane, this circles in the xz plane, this circles in the yz plane, giving us 3 spheres all orbiting around this bigger sphere, and they will never hit each other, they will never run into each other, and they will always stay the same distance apart with those offsets we did. If we put in the same formula into each one of those, they'd be right on top of each other. You'd have 3 spheres, and it'd look like just one sphere moving around here. So we did 2 things here. We put them into separate planes, and we also put an offset on them to keep them spaced around the screen equally. But we now have, and let me just pause here to let the next 200 frames catch up. Okay, at 575 or so out of 600, let's see what we got here. Show animation. We already know what we're going to see. We're going to see 3 of these going around equally at the same speed, but in different planes, which is kind of weird to see. To be honest, I can watch the movement of these sometimes for a long time, longer than I will admit to, just because it's fascinating to watch stuff move around in different planes. I only have 3 things there, and I haven't even touched the lights yet. But we have, as you see, 3 of these moving around, and we'll drag all the way to the end just so we can get the next loop, perfect loop. This would loop continuously. 3 spheres revolving around Mama's sphere, all set to 600 frames maximum. In our formulas, we all divide by 600 frames to make all these numbers come out evenly and smoothly. Next, we can rotate these as they're moving around. You'll see, though, that they're still showing the same face to the camera throughout, including the mama ship. Okay, I also want to make these spheres rotate with each other. But before we get into rotating, let me start talking about breathing and doing what's called easing, which is absolutely impossible to do with keyframes. Keyframes, you can't accelerate, slow down, and then there's just no way to, you go at a constant speed generally. There's no way to go from point A to B at anything other than a constant speed. So we're going to add a breathing to these spheres via the radius. let's add some life into this. For primitive spheres in Mandelbulber, they're not controlled by scale, but by the function radius, which we played with earlier. We already set baby 1, 2, and 3 to do whatever mama ship does. That was smart, because now we're going to make mama breathe in and out, and then now we don't have to play with baby 1, 2, and 3, because they're automatically going to do whatever mama does divided by 4. So let's make mama breathe in and out. How we're going to do that? So we're going to use a sine-based function to gently vary the radius over time. But what we want to do, as frame number increases, we want the sphere to subtly, we want it to shrink slow, stay at that size for a bit, and then accelerate back up. That's just because that's impossible to do in keyframes. We're going to do that in scripting. We call it a breathing effect. It's like when you take a breath, there's a pause at the top and the bottom of your breath before you breathe. So we're going to try to do that with these things. For scale breathing, we don't want harsh motion. So we're going to take, let me show you what we're doing here. We take sine, we make it always positive using the absolute value, and we're going to soften it using the power. Basically, we're going to take it to a power, and that's going to make a slow start, faster middle, slow end. So for our primitive sphere 1 radius, I have this equation here, 1 times 1 plus 1.0. So basically, the 1 is the default value. I want it to, at the 1 value, I want it to grow and shrink, basically, over 600 frames. This POW and this comma 3, that basically this turns this whole thing into to the third power. So it gives a slow start, fast middle, and slow end. And I'll show you what that looks like. In fact, I'm just going to copy right from here, copy, and chunk it right into mama ship radius. Edit script. See we have no script here. Let's paste in that equation that we just got. Let me test it to make sure it works. Looks like it works. We'll do okay, and now we see that mama has a working blue line under radius. That means she has a working script, and hopefully, if we've done our math right, this sphere will shrink and expand over the 600 frames, and these spheres will follow along with it. So now let me delete out all of those images and run the animation. Let's take a look at mama ship's radius. We'll see that at the default value of 1, it is slowly increasing. And I think, if I remember correctly, in the formula, I exaggerated a little bit more just so we could actually see this thing breathing in and out. And look at it, it's getting bigger, it's getting bigger and bigger. It's going to hit its max and then shrink back down, but it's going to pause at the ends. So I'm just going to let this animate. We'll come back to it at the tail end and take a look at the awesome math. Okay, sliding around to 600, that's the end of it. That's it. Show animation. What do we got? So when I scrub through this, oh, look at that. Sphere gets bigger and smaller. Let's let that actually play at real speed, which is going to be a little bit slow for us. Sorry about that. But we're going to see it grows out big. It kind of pauses and gets smaller. Big. And then small. So what we call breathing. The smaller spheres are really small, so it's a little hard for them to tell. It's a little hard to tell on them, but they are also going in and out and breathing. So in 600 frames, and this is just looping and continuing to loop, in 600 frames, the spheres will just continue around, getting bigger and smaller and breathing. So now that we've talked about easing, let me rotate these spheres so that we can see them moving around, not just physically orbiting, but also spinning about in place. And we have 3 axes, X, Y, and Z, that we can spin around in. So we're going to play with that for a little bit. That's just simply going to be rotation. Let me stop that animation. Let me delete all of those images for now. And now let's look at our rotation formulas. So mama ship, let's go back, look at our scripts. We want primitive sphere 1 rotation. As we see, it's a vector, let me say that correctly. Looking at our scripts, we see primitive sphere 1 rotation here. We see that it is a vector parameter. It has 3 components, x, y, and z. In this rotation, our x and y axes are doing nothing but staying at 0, while y is taking 360 times all this to the power of 3, all this absolute value, all this sine, all this 2 times pi times frame number divided by 6. A lot of math, a lot more than just counting to 4. I got it. But I mean, it's not like you're going to be figuring this formula out every time. Basically, it's a pattern. You can chunk your values into it, make them larger or smaller, see how it works, and just test and experiment and keep going. Obviously, there's a great deal of power to actually understanding what's going on here and then being able to get into the guts yourself and program stuff. I use the word program. It's script stuff. We're not programming, we're scripting. Pedantic, I got it. But primitive sphere 1, we're just going to select this. Copy. I'm going to go over into mama ship and paste into the radius of mama ship, which currently has the value of 1. We'll see that that's the script that we already put in there. Boom. Just to make sure. Test, there's an error. So what happened? Why is there an error in our script? So what I have done is I have gone to the radius and not the rotation. I have posted a vector component into a parameter that's expecting a single component. Cancel. Let me see if I still got my script there to go back to it. No, I have messed up the script now. So radius for mama ship. Let me real quick get that back. And it's primitive sphere 1 radius is right here. I wonder why that looked different. Copy. Hey, that works. Now it works. Okay. Back to rotation. Okay, let's get mama ship's radius rotation equation. We want primitive sphere 1 rotation. It's a vector component, x, y, and z. We're going to copy all the way to the end of it. Copy. We're going to go over to mama ship rotation. We can click on either x, y, or z. I always click on y just because it's in the middle. It doesn't really make any difference. Either of the 3 will work. Select all that just to make sure that we get it replaced. We're going to hit test to make sure that that works. And okay. So as promised, mama ship is rotating. Why it didn't turn blue, I don't know. Well, let's get the rotation of all the other ones. So while that's doing that, and we got proof of principle there, let me just stop that real quick. Go to the animation and show you. You'll see that it had a slow start and then sped up. Watch that. Barely spinning, spinning really fast, really fast. Yeah, that's what we want. There's that easing going on. There's let's go and then sphere 2, 3, and 4. Let's get their radiuses. Oh, we don't want radius. We want rotation. Sorry. Rotation. In this case, you'll see that primitive sphere 1 is rotating in the z axis. Primitive sphere 2 is rotating in the y-axis. 3 is rotating in the x. 4 is rotating in the z because there's only 3 axes and there's 4 shapes. So I had to make the mama ship rotate in the same direction as one of them. So let me just chunk that in real quick. Let's go to hyper mode and I'll chunk all 3 of those in. All right, that's all of them chunked in there. Let's delete all those images, render all those images, and I'll see you on the other side. Okay, let's see what we got. The sharp-eyed people among you will notice that I forgot to put in the equation for number 2 and had to go back and do that. Yeah, I also am getting confused on the baby 1, 2, 3, but it's actually sphere 2, 3, and 4. I really should have thought about that a little bit more. My apologies. So let's see what we got. 600 frames. What I'm expecting is I want these 3 spheres to orbit this mama in 3 different planes. I want them also all breathing in and out, getting bigger and smaller. And then I'm also expecting to see this one rotating and these all rotating in different planes. So definitely rotating in different planes, all of it working, all 3 working. Now let's watch this rotation. Are we getting the easing? Long stop. We slowly accelerate, slow down. Yeah, so you cannot do this in keyframes. Just cannot do this in keyframes. That back and forth, slowly doing that. I can add another keyframe. I can change the number of frames, and this sphere will still rotate at this rate in my animation. And that's beautiful. I can do a number of changes. I can move this sphere around, and all these other 3 will follow it around. I can do a number of things with scripting that I just cannot do with keyframes. So, proof of principle, all 3 rotating, and I'm using that power of 3 to do easing. If you increase the power, say to 4 or 5 even, you get more of a pronounced effect, even more of that slow at the beginning, speeding up in the middle, slow at the end. Okay, let's do one more quick thing to demonstrate breathing. This background is fog. The fog visibility is set so that, let me get back on my script here and move it out of the range of you guys so I can talk without you guys seeing what I'm going to say before I say it. So fog visibility in Mandelbulber is controlled by how far we can see. So let me go to effects, volumetric, and basic fog is turned on. The default visibility distance is 20. That means you can see 20 feet and that's it, which is why this entire background has been white this entire time. Were I to add, say, a 0 on that, take it to 200, you'll see, hey, I actually have a background in there and I actually have an image in there. This image is not going to be the one you're going to see. I don't know. Actually, I provided this background as well. It's from NASA. That's right. So courtesy of NASA, thanks NASA. So what I'm going to do is put a script on this fog to, in time with everything else at the same rate, at the same speed. I want the fog to thicken as the motion slows. I want it to clear as the motion speeds up, and I want everything to feel connected. So I'm also going to do the fog in the same easing pattern. Fog background brightness type script, basic fog visibility. I'm going to take us from 10 visibility, I believe, all the way up to like 155 or so, if I remember correctly. Copy this equation as is, go back to this parameter. Still didn't figure out, by the way, during the break, why the rotation values are not blue. So I'm going to have to ask Christoph on that and get back to you guys. So let's get back to this. Doesn't matter what this is because we're going to edit script. The script for the parameter is this 10 plus 160 minus 5 times the power of the absolute value of the cosine of 2 times pi times whatever the frame number is at the time, divided by 600 total, all raised to the 3rd power. Let me hit test on that, make sure that we're working, and it returns a value of 165. So that must be the max at 165. I should have plus instead of minus, I think. I'm not sure if I did that correctly. Anyway, hit OK, and script turns blue. But not the rotation scripts. Don't know why. Okay, we'll find out. Let's run this animation, and what I'm expecting to see is everything moving like it moved before, and we'll see that now the basic fog is going to start out with the visibility being rather high, and the fog will increase. So instead of starting out at the beginning of the video with the fog completely whiting out the scene, it's now going to come in waves in accordance with our script that we have deliberately crafted to time it with everything else. So let me let this run completely, and then let's see what this looks like on the other side. Okay, let's see what we got. show animation, we'll see the first frame is clear because we're going to start with clear and slowly get more foggy as we go on. We're going to let this run in real time, and we'll see. Yeah, the fog also has the same easing as the rotation does, so that we slowly ease into more fog and ease out of the more fog, but accelerate in the middle. Beautiful, beautiful. And we'll see that the blue value for fog indicates there's a script here. So off camera, I'm going to program in the lights real quick, and then also maybe make the background shrink and get bigger in the same easing pattern. That seems to be enough. And then if you load up the finished 4K animation, you'll see all those scripts incorporated, and it should look roughly like the video we're going to have at the end of this. So off screen, let me add all the equations to all those lights. Let me take a look at the scripts we're going to be using. For the background, I'm going to change the basically the horizon and the vertical on the horizon scale in accordance with this same easing formula that we use for basic fog visibility. They're going to track very similarly. On the lights, all of the lights that we're using throughout here are all just going to have this same formula for intensity. I could exaggerate this more. We're not even going to notice the intensity of the lights very much. That's not really the important. The importance here we're trying to see is the position of them. Each one of these lights is going to have a position, which we're going to copy and paste into our formulas. All of the lights are set for their radius to be the same as Mama Sphere, which seems like those would be big lights, but the way the lights work, the size of the lights will look much smaller, even though the radius is set to them. It's also the intensity and other values that we assign to it. So off camera, let me program all this lights, and I'll meet you on the other side. Okay, I have ran the animation after I added all the lights and the background changes. Real quickly, let me run through what we added here. As I mentioned, on the background, I added a equation into the horizontal scale, vertical scale, so that the background will get bigger and smaller as well in the same breathing pattern. And we'll look at the script real quick, edit script, and you'll see that same breathing. We have a pow, we have 2. So not a huge breathing on the background. If I made that a 3 or a 4, we could make that way more pronounced. What else do we want to play with and look at? Let's look at all those lights. Yes, all of those lights. We had 12 lights. So basically, I've added all of the lights in a plane. Okay, let's take a look at the finished animation here in 4K, beautiful 4K color. Recapping what we've done so far, we'll see that the tiny spheres are circling the Mama Sphere. We'll see that each sphere is rotating. We'll see that the background fog is going in and out. And now that we see the lights are traveling around this thing. So let me just run at its natural speed. Now we see each of the lights is rotating the Mama Sphere at some multiple of her radius. I actually got really complicated for the lights. Complicated enough that I had to come up with a graphic to explain it all. Here's the breakdown of my lights. It is so complicated that I had to make this chart for it. I had 12 lights all circling the mothership. 4 of each color, red, green, and blue, are each circling in their own plane, but with offsets to keep them from piling up on each other. So I've got the XY plane with red going. I've got the YZ plane with green going around like that. And I've got the XZ plane with the blue lights going around like that. So 4 lights per plane, each offset to keep them from piling up on top of each other. The size of each one of the lights is set to the main sphere radius, and then the position offset varies with each of the lights. Okay, looking at all of that, we open up the animation and see the lights, as I said. Green ones going in one plane, red in another, blue in the back being the least obvious, going around like this in that plane. Meanwhile, each of the three moons, 1, 2, 3. You can only see two at a time. There's the third one. 1, 2, 3 are also going around in different planes. They're also rotating. The whole animation background is increasing. We see the scale going in and out along with the fog. All of it done. Let's see, that's 12 lights, their intensities, their positions, all scripted. The radius and rotation and position of these all scripted. That's a lot of scripts. That is a lot of scripts. We put in all these scripts to make that whole video. And when we look at the video itself, it's only 600 frames, 2 default stock keyframes, no parameters added to them at all. These 2 keyframes are simply here to tell us start and stop, go for 600 frames, let these scripts completely do their thing throughout 600 frames and basically take us back on a seamless loop. Scripting in Mandelbulber is not about being good at math. It's about understanding patterns. It's about thinking in loops. It's about letting formulas do the repetitive work. And it's about copying and pasting formulas that you make or discover from other people and keep track of them and use them in your library. To aid in that purpose of setting up a library of scripts, I have one of the documents is a template for doing rotations and scripts and breathing and a bunch of other cool stuff. I'll also point out that ChatGPT and other AIs are also really, really good at doing equations like this. If you tell them what you want, hey, I'd like to do a circular motion around the blah, 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 blah. What would be my equation to make something do that? A lot of the AIs can give you really good answers on that. I myself actually spent literal months training ChatGPT to understand Mandelbulber so that I could understand scripting. I will admit here at the end of this video that I have learned scripting from Mandelbulber. Krzysztof Marczak is an awesome programmer, but he's Polish, and so there's a little bit of language difficulty between the two of us. And so I was not able to learn how to do scripting from Krzysztof. He's a busy guy as well. I basically fed in a bunch of these things into ChatGPT and asked it for help. Scripting in Mandelbulber isn't about being good at math. It's about understanding patterns. It's about thinking in loops. It's about letting formulas do the repetitive work. And remember, if a musician that just counts to 4 and starts over again can do it, anyone can do it. Thank you for watching. I'll see you in the next one. I have mentioned 2 other tutorials of mine that might help you on this, whether it's keyframing in Mandelbulber or net rendering in Mandelbulber, and I have several others as well as Krzysztof. Links to those below as well. I also ask that you join us on Facebook at Mandelbulbers with an S at the Facebook site. I'm one of the admins there. You can ask me or anybody else any questions that you have about scripting or anything else to do with Mandelbulber, or share your wonderful, awesome creations there. We'd love to see you. So, good luck. Thank you for sticking with me. I try to make it as painless as possible. I've got a lot of downloadable goodies for you. This is only the first in this series. I'm going to have a more advanced scripting tutorial very soon as I learn how to do more advanced scripting. We have such things as conditionals and variables and a bunch of other cool, awesome stuff that we'll get into here very soon. So, happy fractals. Good luck, and see you down in Fractal Rock.